Steel is everywhere. It's the backbone of our world. Think about it. Bridges, buildings, cars, even your kitchen sink, all steel. But where does this amazing material come from? It all starts with a simple ingredient: iron. Iron is combined with carbon and other elements in a super hot furnace. This creates steel, a material that's both strong and versatile. Without steel, our world would be a very different place. We wouldn't have the soaring skyscrapers or the long-lasting bridges. Our transportation systems would be primitive, and many everyday items we take for granted wouldn't exist. Steel is a testament to human ingenuity. It's a material that has shaped our history and continues to shape our future. So next time you see a towering skyscraper or drive over a massive bridge, take a moment to appreciate the magic of steel. You might be surprised to learn that steel is one of the most recycled materials on the planet. That's right, the steel in your car might have once been part of a building or even a refrigerator. It's all thanks to scrap metal. Scrap metal comes from all sorts of places. Old cars, demolished buildings, and even discarded appliances all end up in scrapyards. These scrapyards are like giant recycling centers for steel. The scrap metal is sorted and processed, getting it ready for its next life. Giant machines crush and shred the metal into smaller pieces. These pieces are then transported to steel mills, where they'll be given a new purpose. It's a beautiful cycle. Old steel gets a new life, reducing waste and conserving resources. So the next time you recycle a can, remember that you're contributing to the amazing journey of steel. The heart of a steel mill is the furnace. This is where the magic happens, where scrap metal is transformed into molten steel. It's a scene straight out of hell-roaring flames, blinding sparks, and temperatures so high they'd melt your boots off. The most common type of furnace is called a basic oxygen furnace. It's a giant, pear-shaped vessel lined with heat-resistant bricks. First, they load the scrap metal into the furnace. Then they blow pure oxygen into the mix. The oxygen reacts with the scrap, creating an intense heat that melts the metal. We're talking temperatures over 3,000 degrees Fahrenheit. The impurities in the scrap metal burn off, leaving behind a pool of glowing molten steel. It's a dangerous job, no doubt about it, but the steel workers who operate these furnaces are a different breed. They work tirelessly in the heat and noise, ensuring the steel-making process runs smoothly. Section 4. Recipe for strength refining and alloying. Once the scrap metal is melted, it's time to refine and alloy it. Think of it like baking a cake. You start with basic ingredients, then add others to create the perfect flavor and texture. The molten steel is poured into a ladle, a giant bucket lined with refractory brick. Then, they add different materials to fine-tune the steel's properties. This is called alloying. Want stronger steel for building bridges? Add some nickel. Need corrosion-resistant steel for pipelines? Toss in some chromium. Each alloying element brings something unique to the table. The molten steel is carefully analyzed throughout the process. They take samples and test them to make sure the composition is just right. It's a delicate balance, but it's crucial for creating high-quality steel. Section 5. From liquid to solid, shaping the molten metal. The final step in the steelmaking process is casting. This is where the molten steel takes on a solid form, ready to be transformed into countless products. There are several methods for casting steel, but one of the most common is continuous casting. In this process, the molten steel is poured into a mold that's constantly moving. As the mold moves, the molten steel begins to cool and solidify. The result is a long, continuous strand of solid steel. This strand is then cut into smaller sections ready for further processing. These sections of steel, called billets, blooms, or slabs, are the building blocks for countless products. They can be rolled into sheets, formed into tubes, or drawn into wires. The possibilities are endless.